Hello, and welcome to another video, Let's Study video on programming principles and practice using C++, 3rd edition. Last we left off, we completed the terms section of Chapter 1, Hello World, and now we'll be moving on to the exercises. Before we move on to the exercises, after listening to my video on the car ride to work, actually from work to home, I think I got library wrong, or at least I found another definition of library during my shift. I was able to read some from my other book here. Applied computational physics, and let's see if I can find it real quick. Alright, so we have the building programs in a Linux environment, and we're looking for, here we go, libraries and library tools and compiling from multiple units. So we're looking for page 16. Here we go. Alright. So we'll see this later, or at least I'll use this technique later in programs and examples. But we have here in section 1.8, libraries and library tools. Having seen how to break up the source code into more manageable units, we now address the issue of how to keep the compiled code together in order to ease the process of compilation. Files containing object code with the .o extension are often collected together into libraries, so that the client iterate that CPP in the example above. So, I mean, some of this context is missing because we're not reading this book yet, but we'll get to this book eventually. That's actually the goal. But, so I'm not sure if I want to talk about separate compilation. But effectively, when we compile our CPP files into object files, we can take these object files and put them into libraries. Okay, so files containing object code with the .o extension are often collected together into libraries, so that the client code, iterate.cpp in the above example, can link with one library rather than many different object files. In the world of professional programming, the library and associated header files and documentation is the implementation of what is called the API, or Application Programming Interface, which represents a toolkit for the development of applications, vulgarly referred to as apps amongst the rabble. I love that line. There are two kinds of libraries, called static, files ending with a .a, and shared, files ending with a .so on Linux systems, or with .dylib on the Mac. The main difference is that at link time, the object code in static libraries becomes part of the executable file, i.e. it's copied in. Programs linked to a shared library contain only pointers to bits of executable code, which are not copied into the executable, and therefore the shared library file must be resolved at runtime before the program can be executed. Working with static libraries is usually simpler, though it does create larger executables. The Linux command AR manipulates a static... Oops, sorry. Getting used to the zoomed in camera. Alright, I guess you're just going to be missing some of that text. We here don't aim for perfection in making videos. The Linux command AR manipulates a static library. To create the static library, libiterate.a, give the command arrc libiterate.a, initialize.o, executable.o, execute.o, and finalize.o. So these are multiple object files, and we're creating one file, a library file, ending with the extension .a. Okay. The modifier RC stands for replace and create. The library or archive, I guess A for archive, I think. And I guess this is a static library or archive. God, these terms are getting a little fuzzy. Is created if it doesn't exist. And if it does exist, then any object files within the library are replaced by those given on the command line. The contents of the library can be examined with ART. So we see ART, libiterate A, and we can see what object files were put into libiterate.a. Also, the contents of the library can be manipulated. For example, individual pieces of object code may be extracted, ARX, or deleted, ARD. More information can be obtained from the AR manual page. So what is AR? Is what I'm thinking right now. I don't know. Okay, but here's I don't want to skip ahead, but here's what I'm looking for. So let's get there. Now that you've built the library, you naturally will wonder how to link it to other code. The G++ command has two important compiler flags that can be used. -L, with capital L, and -L, again, lowercase l. The first one, -L, specifies a directory to be searched for the library. The working directory is not on that path by default. So if your library lives in your working directory, you should add -L or -L pwd in single quotes to the G++ command. The second one, -L, gives the name of the library to link, but with an odd rule. To link to libiterate.a, you should write -L iterate. In other words, transfer lib into -L and drop the extension .a. Not confusing at all. Both flags can be repeated on the command line and specify a search list. If the library is not found in the first directory, the second is searched. Likewise, if the symbols are not found in the library on the first command line, the second is searched. Therefore, an order of -L and -L arguments is important. In our example, we will use the command this. So this is the command we're looking for. So we have G++, iterate.o, -L, L iterate, -O iterate. Okay, so we're creating an iterate executable using the object code from iterate.o, linking in our current directory that -L dot, that dot is a current directory, and we're looking for iterate.a with the -L argument. Okay. This is how G++. Okay. What does that look like? Looks like we got things on shared libraries. An example of a shared library, the GNU Scientific Library, GSL. We can get that later. Okay, I'll just leave that there. Go back to the edge of where we've been. Okay. Alright. We have our exercises for Chapter 1, Hello World. We list drills separately from exercises. Always complete the chapter drill before attempting an exercise. Doing so will save you time. So yes. So we did the drills, which were... That's what I don't like about zoomed in, because when I flip a page, I want to show like the whole section. I can't show that, and I can't quickly move the camera. Okay. Doing so will save you time. So, before the drills for Chapter 1, we're setting up effectively a Hello World, exactly a Hello World program. But of course, as anyone knows, setting up your Hello World program is actually a butt ton of work, and getting everything set up. So, getting a developer environment set up. So you have somewhere to edit files, you have somewhere to compile, then you can run those files, possibly do some debugging, and also edit them within an interactive development most of the time. So that's why this one totally wants us to do the drill before we do the exercises. So, exercise 1, change the program to output the 2 lines. Hello programming, here we go. Alright, so let's just jump right in. It's obviously not a very difficult exercise to start off with. Let's open up Visual Studio. Create a new project. An empty project. Empty C++ project. Hold on, let me see if I can increase the text scale. Oh, my keyboard is way over here. Alright, it doesn't look too horrible, although my mouse cursor is really, really small. And other things have broken. Alright, well, we have Visual Studio here. Okay, well, it's better readable for you. So let's create a new project. Empty project. Hit next. Give this project name. Let's see. Okay, wait. This is actually an exercise, so we have PPP free. Exercise 1.1. So, chapter 1, exercise 1. Press enter. We'll build this project. Okay. Alright. Doesn't look too bad. Okay. Let's go to source files. Right click. I want to add a new item. Let's just call this main. Right click the exercises, not the exercise, right click the project properties, scroll down, go to C/C++, open that up. We have the language. We want to change the language standard to latest, and to build the ISO C++ standards library 23 to yes. And then we want to go to general, additional, module, scan sources for module dependency. We're not going to use it, but we want to turn it on anyways. Got apply, hit OK, and now we're ready to go. So we hashtag. We don't hashtag. We start with this program. Outputs run message below. And that is hello programming. And here we go. Alright, we flip back to the book. And I'll briefly show it. So this is the program that we'll be using. That is the hello world.cpp. So we have the import, we have the std out, and yeah, it's a simple hello world program. And so we're going to just sort of transcript that right back into our example. Well, not our example, but our solution to exercise 1 here. Okay, so I don't need to make it that small. I can make it bigger. Okay. Alright, so let's import std. Alright, save. Now, why isn't this blue? Never mind. All good. Alright. Int name. Squeeze this down. std c out. Output operator. That's hello world. Is that what we're supposed to be saying? No. Hello. Programming. I want to print it. And new line character. Now we can do this in 2 statements, or we can do it in 1. I will prefer to do it in 2 statements with this example. I'll show it working in 1 statement as well in just a second. Alright, so that's all we really need to do. We can just hit run at the top. Alright, hello programming, here we go. Alright, so it works. But we can also do this. I can take this line, place it in here, and we run this, we'll also see that this works. The reason why this line down here didn't stay on 1 line is because of this new line character. So the computer types this out, and then with the new line character, it'll drop the cursor down. So hello programming, then drop it down, and then begin there. And so, and what happens here is that this gets evaluated first, and the output of this sort of grouping right here is just std cout. So cout. So we have std cout, this. So this gets done first, and then effectively it goes away, and then the next one is done, and then the next one, and then, well, that's nothing, and it goes on. So that's effectively what's going on, best I can say. So I will leave it as this. Next file, save all, and yeah, easy peasy. Alright, so that finishes exercise 1. Now I'm moving to exercise 2. Expanding on what you have learned, write a program that lists the instructions for a computer to find the upstairs bathroom, discussed in Chapter 1, Section 1. Can you think of any more steps that a person would assume, but that a computer would not? Add them to your list. This is a good start in thinking like a computer. Warning: for most people, go to the bathroom is a perfectly adequate instruction. For someone with no experience with houses, bathrooms, imagine a Stone Age person, somehow transported into your dining room. And the list of necessary instructions could be very long. Please don't use more than a page for the benefit of the reader. You may add a short description of the layout of the house you are imagining. Okay. Let's close this. Visual Studio again. Oh no. Almost didn't show you it. Riveting stuff. Creating empty projects. Alright, so PPP3 exercise 1.2. Source files, add new item, name, project properties, general, edit this to what? So language first, I guess. Preview, build. I'm confused. I also have a camera in the middle of my face. Okay, properties. Okay, no, this is what we wanted. Here, get read. Okay, so let's go back to section 1.1 because it's been a minute. Read it real quick. To get a computer to do something, you, or someone else, have to tell it exactly, in excruciating detail, what to do. Such a description of what to do is called a program, and programming is the activity of writing and testing such programs. In a sense, we have all programmed before. After all, we have given descriptions of tasks to be done, such as how to drive to the nearest cinema, how to find the upstairs bathroom, and how to heat a meal in the microwave. The difference between such descriptions and programs is one of degree of precision. Humans tend to compensate for poor instructions by using common sense, but computers don't. For example, turn right in the corridor, up the stairs, it'll be on your left, is probably a fine description of how to get to the upstairs bathroom. However, when you look at those simple instructions, you'll find the grammar sloppy and the instructions incomplete. A human easily compensates. For example, assume that you are sitting at the table and ask for directions to the bathroom. You don't need to be told to get up from your chair, to get to the corridor, somehow walk around, and not across or under the table, not to step on the cat, etc. You not have to be told not to bring a knife or fork, or to remember to switch on the light so that you can see the stairs. Opening the door to the bathroom before entering is probably also something you don't have to be told. In contrast, computers are really dumb. They have to have everything described precisely and in detail. Consider again, turn right in the corridor up the stairs. It'll be on your left. Where is the corridor? What's a corridor? What is turn right? What stairs? How do I go upstairs? 1 step at a time. 2 steps. Slide up the banister. What's on my left? When will it be on my left? To be able to describe things precisely for a computer, we need a precisely defined language with a specific grammar. English is far too loosely structured for that, and a well-defined vocabulary for the kinds of actions we want performed. Such a language is called a programming language. Thus, C++ is a programming language designed for a wide selection of programming tasks. When a computer can perform a complex task given simple instructions, it is because someone has taught it to do so by providing a program. If you want a greater philosophical detail about computers, programs, and programming, see PPP2.chapter 1 and PPP2.chapter 22. You can find those on www.strauchdub.com. Here we start with a very simple program and the tools and techniques you need to get it to run. So that's section 1.1. And then we have our exercise. Expanding on what you have learned, write a program that lists the instructions for a computer to find the upstairs bathroom. Alright, can you think of any more steps that a person would assume that a computer would not, and add them to the list? This is a good thing. Thinking like a computer. Warning for most people, go to the bathroom is perfectly adequate instruction. For someone with no experience, a house is a bathroom. It's okay, so I repeated some of this. Please don't use any more than 1 page. Okay. Find the upstairs bathroom. Alright, so, well. Assumed position of at a dinner table. These out. This will be table seated in a dining room. Going to use liberal use of our ability to put our lines anywhere, and we'll go off of this. Okay, so let's start. Alright, it's a page. I think I'm going to define a page as 100 actions, so we have from line 10 to 110. So let's be specific. Alright, so assuming you are at a table seated in a dining room with a room. Dining room. I'm just going to state assumptions. I'm not sure it's useful for the program itself, but the programmer, for us, makes sense. Or should I leave this as a comment? I will assume it's a comment. I'll make this easier on myself and say with a bathroom visible from said table. No use making it more difficult on ourselves. So, starting conditions. Place any objects within hands on top of table. Give us some line numbers. Okay, this is better. Held. And hands. Scooch back. Chair. Some legs. Stand up. Step 1, chair width to either a right or a left, whichever most free. Now like this one. Right. Person. Well, actually, look around the room till you see a white door with a sign. Restaurant. If not found, ask for directions. Alright. Found. Path. Most easily available to walk to the restroom. Walk in. I don't want to begin walking. Step either to your left or right. One chair width. Push in your chair you are sitting in until flush with table. Don't have to tell him or her to let go, him, her, or it, the programming robot. To let go of the chair because we never grabbed onto it. Let's make some assumptions up here as well. Assumed person can stand up. See the position. Is literate. shuffle. And grab. Can walk, shuffle, can walk. Stand up. So I'm writing down my assumptions of this person that we are programming. I am taking this a bit more seriously than would be necessary. But it certainly got my mind working with thinking about how I might be programming a robot to take this task of just moving from one room to another. Thinking of like object avoidance and all of that goodness. I'm also very tired and my head hurts. We shall press on. Okay. We'll add to this assumptions list as we need them. Is that how we might say it? COOTCH? This seems like Scotch. And we drop the T. That seems right. Scooch. I don't want scooch though. Move chair length distance back by pushing. path to the restroom while avoiding obstacles. They include to medium size objects. Yeah, I wanted to find obstacles. A bit too much. If an obstacle is encountered, stop and assess if the obstacle can be moved. Obstacle can be moved. Very briefly, to see if it will move. Say excuse me. Alright. Speak. Walk, stand up, grab, push, place, turn objects, speak. Perhaps encourage. Things to know. Path. If no obstacles in path, return to walking. If the obstacle cannot be moved, find a new path. Stop and arm's length away. Knock on door twice. Audibly. Alright, can walk, speak, stand up, grab, push, place, and okay. Good knock. Knock on. So we have assumptions here. Shows what a door handle looks like. We also have assumptions about geometry. Knows how to determine the length, width, height of objects. Heard. Wait. Until minutes. Yeah, 10 minutes seems fine. Which direction? Hold on. Check my door. I think it's clockwise. Yep, clockwise. My head is going to explode. Ooh. Clockwise. rotation or until resistance is felt. Okay, so we assume those rotation along axes. Objects. Clockwise and counterclockwise. Pull, open door. Roughly 10 degrees. Open. Or does not budge. We have force. I'm trying to read my code with a big camera in my way. It's not a big camera, but this giving me like this double vision as my eyes see this double image in front of me. Let me do this. Dork knob. Doorknob. Man, my head hurts. Take some acetaminophen. How the hell do you spell quiet? needs to go. It doesn't look too bad. Just sync. Okay, assume. Okay, missing the assumptions up here as well. Add these to the program. Assuming you are at a table seated in a dining room. Then a home with a bathroom, with a white door, with look. Assuming you're at a table seated in a dining room within a home with a bathroom with a white door with restroom written on the door. The door has a handle on both sides. Internal door handles. Has a handle on both sides. Internal. Assuming you're at a table seated in a dining room within a home with a bathroom, with a white door, with restroom written on the door. A bathroom's door has a handle on both sides. A bathroom's door has a handle on both sides. The internal door handle has a push lock on it, visible. Bathroom is visible. assuming you're at a table seated in a dining room within a home with a bathroom with a white door with restroom written on the door. A bathroom's door handle has a handle on both sides. The internal door handle has a push lock on it. The bathroom is visible from the table. Assumed a person can. Starting conditions and the requisite knowledge stated above. So, assuming you're at a table seated in a dining room within a home with a bathroom with a white door with restroom written on the door, a bathroom door has a handle on both sides, the internal door handle has a push lock on it, the bathroom is visible from the table. Visible, I misspelled that. Assumed a person can. Assumed a person can read and understand the word restroom. Maybe not understand, but can read. Just read the word restroom. Read the word restroom, can hear quiet sounds, walk, speak, stand up, grab, push, place, knock on, and turn objects. Knows how to determine the misspelled that really bad. Length. Width. The length, width, and height of objects. Actually, height doesn't come into play, I think. It's easy to assume that. Knows rotation along axis of objects by clockwise or counterclockwise, so it just understands what clockwise and counterclockwise is. Knows what a door handle looks like. Do we assume that? Okay. Knows what a door, chair, table, door handle, obstacle. Knows what a door, chair, table, door handle, and obstacle looks like. Knows the color white. White is not really a color. Assume the person can read the word restroom, hear quiet sounds, walk, speak, stand up, grab, push, place, knock on, and turn objects. Knows how to determine the length, width, and height of objects. Knows rotation along axis of objects, but clockwise and counterclockwise. Knows what a door, chair, table, door handle, and obstacle looks like. Knows that flush means objects. Right. has legs. We mentioned them. We have to assume they have it. Oops. Alright. Begin program, assuming starting conditions and prerequisite knowledge. Woo! Where'd we go? State above? Stated. Stated above. Alright, step 1. Place any objects held in hands onto the table. Now, I will just say held. I don't have to specify hands, but nah, that doesn't work. I'll just say that anyway, so I can get away with it. Place any objects held onto of table onto the table. Move a chair length distance back by pushing with your legs against the floor, otherwise known as the scooch maneuver. Scooch back. Step 3, stand up. Step 4, look around the room until you see a white door with a sign. Restroom. That's to say with the word restroom. If not found, ask for better directions or to be pointed towards. Or to be pointed. Or restroom to be pointed out. If found, look for a path most easily available to walk to the restroom. Step either to your left or right, 1 chair width. Push in your chair. You were sitting until flush with table. Proceed down the path to the restroom while avoiding obstacles. If an obstacle is encountered, stop and assess. Yep, two S's. Assess if the object can be moved. Alright, that's a new assumption. If an obstacle is encountered, stop and assess if the obstacle can be moved. If the obstacle can be moved, wait briefly. To see if it will move. Oh shit. Okay, sorry. Excuse me. Those. Excuse me. No. In order to do this multi-line edit, this is something that is not seen in most applications. Hold Alt and drag down, and now you have a multi-line cursor. So when I hit escape, I delete a character. Several lines all at once. Very helpful, extremely helpful with these types of programs. Okay. I think we're about done. If an obstacle is encountered, stop and assess if the obstacle can be moved. If the obstacle can be moved, wait briefly to see if it will move. Say, excuse me. To perhaps encourage living things to move. Pretty much anything will react to sound, and people will leave. If the obstacle cannot be moved, find a new path to restroom. Not much here in obstacle. Well, yeah, there's a bit here in obstacle avoidance. Okay, upon reaching restroom door. Stop an arm's length away from door. Knock on door twice audibly. No sound is heard. In response. Heard back. Grab door handle. If sound is heard, wait for 10 minutes. Proceed to step 15. Else, continue with program. Turn the door clockwise with rotation. Attempt to pull open door roughly 10 degrees open. If door does not open, return doorknob to original rotation. Turn the doorknob counterclockwise one full rotation or until resistance is felt. Door does not open, wait 5 minutes before trying again. Door opens roughly 10 degrees while stepping out of the way of the door, pull on the handle till the door opens at least a person's width. Let go of the door handle, walk into the bathroom, grab the other door handle. Ah, we missed a new line character on 25. Right, there we go. Grab the other door handle. Instead of other, let's internal door handle. Or the door back. Feel the door handle moving back as well till the door is flush with the door frame. And let go of the door handle and push the lock button on the door handle until an audible click is heard. Program complete. Yep. I'm happy with that. This written for PPP3 exercise 1.2. this is adequate. Now, we're not assuming a Stone Age person like we just wrote. We're assuming a person that can do things that quite think, frankly, can do more than just caveman stuff. It would be considerably harder for a caveman and considerably harder to program a robot. I think that's done. That's a funny one. Alright, so exercise free. Write a description of how to get from the front door of your dorm room, apartment, house, whatever, to the door of your classroom, assuming you are attending some school. If you are not, pick another target. Have a friend try to follow the instructions and annotate them with improvements as he or she goes along. To keep friends, it may be a good idea to field test those instructions yourself before giving them to a friend. Well, I don't have any friends in person who would be willing to do this, so I can't quite do the third exercise. Alright, moving on. Also, I really don't want to do more instruction stuff, but oh gosh, look at this. Alright, find a good cookbook. This is no surprise to me. Find a good cookbook. Read the instructions for baking blueberry muffins. If you are in a country where blueberry muffins is a strange, exotic dish, use a more familiar dish instead. Please note that with a bit of help and instruction, most of the people in the world can bake delicious blueberry muffins. It is not considered advanced or difficult fine cooking. However, for the author, few exercises in this book are as difficult as this one. It is amazing what you can do with a bit of practice. Rewrite those instructions so that each individual action is its own numbered paragraph. Be careful to list all ingredients and all kitchen utensils used at each step. Careful about crucial details, such as the desired oven temperature, preheating the oven, the preparation of the muffin pan, the way to time the cooking, and the need to protect your hands while removing the muffins from the oven. Consider those instructions from the point of view of a cooking novice. If you are not one, get help from a friend who does not know how to cook. Fill in the steps the books offer, almost certainly an experienced cook, left out for being obvious. Build a glossary of terms used. What is muffin pan? What does preheating do? What do you mean by oven? Now bake some muffins and enjoy your results. Okay, so I wonder where it went, but I printed out a muffin recipe somewhere specifically for this exercise. I read ahead a little bit, which is not a bad thing to do. Never a bad thing to do, to be honest. Even during a time to test. Muffins. Where did I put the muffin recipe? One moment. Okay, so I can't find the recipe that I printed out, and I wouldn't have the ingredients anyways if I had them. And with the exercise being so similar to the exercise 2 that we spent way too much time on, I'm going to call that done on the exercises for chapter 1 because exercise 5 is to write a definition for each of the terms from terms, the term section, and, well, we already did that in the previous video. Okay, so my head is exploding. I'm gonna rest up a bit, and I think I will read at least a few sections of chapter 2 of on objects, types, and values of programming principles and practice using C++ 3rd edition. See you guys in a moment or tomorrow. Not sure when, but you'll get the video eventually. Hoping I'll feel better and be able to get more videos out.